So we are now calling this Runoff to Resilience. It's also called BrightStorm, so you may have heard either of those. And I'm just going to give sort of a quick overview of what this is, and then happy to answer questions. I'll just say right now that I am not on the technical side of this, so I'm not an engineer. So if you have really specific questions about the engineering, we'll have to get back to you and have our technical team help answer those. So just wanted to start with a little bit of an overview of the Nature Conservancy. Our mission is to conserve the lands and waters on which all life depends. And our vision is a world where the diversity of life thrives and people act to conserve nature for its own sake and for its ability to provide us with the things that we need. So we're not focused solely on protecting places from people, but we want to find solutions where we can protect nature by engaging with people. And we operate in 80 different countries around the world and have offices in every state and territory in the United States. BrightStorm is a program of TNC. It started a few years ago, and it was born out of the idea that we're not going to be able to tear down cities, but rather we need to figure out how to address water infrastructure problems so that we can maintain the health of our freshwater systems, our rivers and estuaries, and then eventually our oceans. So BrightStorm is thinking about how we can reprogram our cities using infrastructure and technology to make them act more like nature. BrightStorm focuses on using technology to identify, design, and implement novel solutions in water management. So the BrightStorm team works across North America. They test technology and models that promise to help address these issues relating to flooding and water quality. And then the Florida chapter is involved because we're working on a pilot project in the Indian River Lagoon. And so that's what I'm going to focus on today is this 5-year pilot project. It's a research project that we think has the potential to address water quality. This will be another tool in the toolkit. We don't think this is the silver bullet, but we think this could be another way to manage stormwater that could be incorporated into existing work. With new generative artificial intelligence, machine learning technology, and advancements in smart stormwater management technologies, we can now start to create these networks of stormwater ponds to improve water quality. And we want to test that theory in the Indian River Lagoon. So why did we choose the Indian River Lagoon? This is a project that we see, if successful, would be implemented across Florida and also nationally. But there were lots of reasons to choose the Indian River Lagoon for this pilot project. First, there are a lot of stormwater ponds. There's something like 14,000 ponds across the Indian River Lagoon. About 80% of those are privately owned. So that means that counties and cities aren't necessarily looking across all these private ponds as opportunities to retrofit. So we saw that as an opportunity to start to explore sort of what infrastructure already exists and what might be possible in the future. There's also a lot of rainfall here, so that kind of sets us up for a good test model. And then we know that the region has a strong commitment to collaboration. There are regulators, policymakers, and implementation partners who've been doing this for a long time, so they know what has worked and what hasn't. They have a good understanding of sort of the landscape of this region. And also understanding permitting, what's possible and what's not through permitting. And we found that there's political will to try new solutions in this region. So historically, stormwater ponds have been built to protect us in flood events. And so they fill up during flood events and then they slowly release back that water back into our rivers and estuaries. The intention is both flood protection, but also to give time for the nutrients and sediment to settle out before the water moves out of the pond. And that helps improve water quality of the systems where that water is being released. But it doesn't always work that way because these ponds are all built essentially in the same way and they're not connected. They don't talk to each other. So this is similar to a lot of planes coming into land at the same time. They all fill up at the same time, and then they all, in theory, release at the same time. So what we're thinking about is, can we use these smart stormwater ponds? We're already seeing these being installed in Florida and swap out that outflow with a real world sensor that knows how much water is coming in, how much water is going out, and then it can be connected to weather predictions so that in advance of a storm, the system could potentially move water around to create more capacity in certain ponds. And then after the storm, it could hold that water back longer to allow for more settlement of the nutrients and sediments, so that when that water gets released back into the system, it is in theory cleaner. So this would be replacing existing valves with smart valves. And if we connect existing storm ponds together, we can create this desired future state, which is like air traffic control for water. So it's just a more advanced, smarter system that can be sort of considering the actual real world implications of where this water is. So these ponds then in theory can talk to each other, potentially increasing the amount of time of detention, which would improve water quality and also potentially flood protection within a given watershed. So this is a diagram of how these smart ponds could work using a control panel that's pulling data from multiple sources to make real-time decisions about when to release and hold water from an individual pond. But I want to draw your attention to the photos on the right. So the top one has sort of a normal, it's a normal structure, and the bottom one shows one of these smart ponds. And you can see that the water coming out is much cleaner in the bottom picture because it's been held back longer, which gave it more time for the sediment to settle out into that pond. And after 10 years of these types of installations, there are billions of data points on how this tech works. So we can use that in conjunction with advancements that have been happening more recently around machine learning and AI. So there are lots of companies who are already starting to use these advancements to better understand things like weather systems and climate. And figuring out how to incorporate those new advancements is a core part of this project and what BrightStorm is working on in general. So BrightStorm is not just working in Florida. This is one pilot, but they're working on nationally. So we can now use predictive analytics to create what they call a digital twin. And then the system can get smarter over time as some of these decision points become automated based on past results. So in theory, this system is learning all the time and better managing water over time as it learns. So we can build in those two key components to create this coordinated watershed that learns and adapts over time. In the future, this model could look at weather data, how these ponds are connected to monitor that inflow and outflow, and then the program would be able to predict the optimization between these different connections. So it might choose to move water from one pond to another to create more space. It might hold water longer to allow those nutrients and sediment to settle out. But the point is that it could, in the future, hopefully be automated so that this just happens seamlessly. You don't need someone sitting somewhere to push a button to make it happen. It would all just happen on its own. So just a little bit about sort of where we are now. We're about a year into our 5-year pilot project in the Indian River Lagoon. So we've spent that time putting together a team, which includes TNC's BrightStorm team that works nationally, a team based here in Florida, which is me and Christiana and a couple other people, and then some outside experts. So we have local consulting experts, including Jones Edmonds. If you're familiar with their work, they work in the region a lot on stormwater issues. We have international experts in machine learning, hydrology, and hydrologic modeling, ARUP. We've also been working with Opti. The lead of the BrightStorm team helped found that company, and they have expertise in continuous monitoring and adaptive control, or CMAC. And that technology is used when you take a passive pond and make it a smart pond. We're also working with university and research partners. So we have someone from the University of Florida is going to be doing pre and post monitoring of water quality, coming sort of into and out of wherever we do this pilot. So it won't just be monitoring in the Indian River Lagoon, but understanding actually like when you come into the canal that comes out from those ponds, what is the difference sort of inside those canals and then on the outside to see, if the water quality is better, which is our hypothesis that it will be. And then we also have experts at the University of Michigan who are advising on machine learning. And we have a partnership with Amazon Web Services. They have an AI machine learning nonprofit arm, and they're helping us think about how to build that digital twin, which will be important as we start to scale this up down the line. So what we've been working on over the last year, the AI machine learning technology is being used in two different ways. One of the ways we're using that is doing modeling to look across these 14,000 ponds in the Indian River Lagoon to see where we have opportunities to have the greatest lift. Obviously, we want this project to be successful in what we think that it's going to do. This smart watershed approach might not be the right option for every set of set of stormwater ponds. So we're trying to use this modeling to understand where it might work best. We've narrowed that to about 12 locations, but what's important is that the model itself could end up being a really important tool that people can use in the future to help plan either this kind of project or others. Oh, sorry. So then we've also been meeting with different agencies of partners that are local because we want to make sure we're getting input on whether what the model is saying actually makes sense in the real world. So we've been meeting with counties and cities, the National Estuary Program, and just trying to get some feedback on what the modeling is telling us. So we have developed a methodology using an open source version of a modeling tool called the aggregated storage model to replicate control decisions on a drainage network at unprecedented speeds. So you can see here, this model is running 1,000 times faster than it did previously. So again, this is another tool that's been built as part of this that will be useful. This will all be open source, so it will be useful to other people in the future in any kind of stormwater modeling efforts. And as a result of building the model, we found other ancillary benefits, such as, so this is the aggregated storage model. It was built by Arup, our partner on this project. But like I said, it didn't previously exist. So we're hoping that these tools that we're building will be useful to people in the future. And then the future of this is for the decision-making to be fully automated, for the system to learn over time, to be better able to adapt to changing conditions, which we all know even the conditions are changing all the time, but they're going to likely be changing even more significantly in the future with climate change. So like I said, we're just getting started on this pilot project, but what we're trying to do is while we're working on this pilot project in one area, we haven't decided yet, but we've definitely narrowed it. The aim is to be also building partnerships and then show that this proof of concept through the pilot that we can easily scale this work. So we want to be starting to have these conversations so that hopefully when we're ready to scale, people are sort of on board and have heard this concept. So we're building relationships, socializing the ideas so that we can expand once we hopefully show that this pilot is successful.